Okay, so let's look at gravitational potential energy. Okay, gravitational potential energy is given by this. V, you will see, is the symbol used for potential energy. Okay, potential energy, remember we look at gravitational and elastic potential energy, which is the potential energy in a spring. Okay, anyways, the point is V, we use the symbol V for potential energy. Vg is gravitational potential energy. It's equal to the weight times y. So you can see it's similar. Recall the work of a weight looked something like this, minus W delta y. Okay? So there's similarities between the work of a weight and the potential energy due to gravity. You can see there's the weight and there's a change in y here. You can see there's a weight and then there's the position. So they're very similar, okay? But we'll see one small difference, hopefully, if I remember it. But nevertheless, okay, so how do we apply this equation? What does this mean? Well, let's have a look at this diagram over here. Let's erase this. So say now you have a particle anywhere in space. The first thing we need to do is we need to define our datum. You define it, okay? Based on the problem, based on how you feel, you define where your datum is. So if your particle, okay, so remember Vg is Wy. Okay, so this is the potential energy due to gravity. If the particle is at the datum, then y, y refers to the position of the particle. Y equals 0, that means the potential energy is 0, okay, at the datum. If the particle is above the datum, then we have a plus y, which means we've got positive potential energy. And if the particle is below, we have negative potential energy. All right? So, as you can see, we're just looking at, whereas the work of a weight looked at the change in y, the work of the weight looked at the change in y. How much work did the weight do as it moved from one point to the other? What we're looking at here, it looks very similar, but what we're looking at here is simply not the change in potential energy yet. We're just looking at the potential energy at a certain point. What is the potential energy there? What is the potential energy? What is the potential energy there? Okay? So take note, datum, if it's above the datum, you've got positive Wy. If it's below the datum, negative Wy. And really what this means is, if you've got positive potential energy, I hope you take note here, then there is energy stored. Okay, there's energy that's stored here that allows the weight to do positive work to bring this back to the datum. If we have negative potential energy, then the weight needs to do negative work to bring it back to the datum. I'm going to repeat that. If there's positive energy, then the weight can do positive work to bring it to the datum. If there's negative potential energy, then the weight has to do negative work. Positive potential energy, positive work to the datum. Negative potential energy, negative work to bring the particle to the datum. Okay? See you in the next one.